Okay, so we're gonna do a little bit of work, kind of starting into our applied arithmetic or financial maths. We're gonna lead into it with some fractions, decimals, significant figures. Okay, a lot of this should be fairly fundamental stuff, fairly foundational stuff. So fractions are equivalent if they have the same value. To add or subtract, we find a common denominator. To multiply, we multiply the numerator by the numerator and denominator by the denominator. So that's your top by top and bottom by bottom. To divide, we find the reciprocate of the second fraction and we multiply. Okay, any unit can be written as a fraction. We write the part we're looking at as a fraction of the total amount. So if you get 50 out of 80 in a test, then you would write that as 50 over 80. Okay, or 5 over 8 if we break it down. 7 over 7 or 4 over 4 represents 1, which is generally, I suppose, the original amount. So that would be the total or the full amount or the original amount. A recurring decimal is one where some decimal places repeat indefinitely. So I skipped over as well the second one. We'll go back to that. So a recurring decimal is one like 1 over 6, which becomes 0.1666666, or just 0.16 with the little dot. And the little dot just means recurring. So that's this little dot here. Then, so looking at the next bit, then to round a decimal to a certain number, we go to the required number of places, and then we're going to look at the next number. And if that number is 5 or bigger, then we're going to round up. If it's below 5, then we do not round up. Okay, then we stick where we are. So looking at these few examples that we have, we're going to find 3/5 of 40. So we take our question 3 over 5. If we're trying to find a fraction of a bigger number, that's going to mean multiplying. So we're finding 3/5 of 40, we're multiplying the two options that we have, and we get an answer of 24. That's the first part. Second part then, Orla has read 120 pages of her book, which makes her 4/7 of the way through. How many pages are in the book? Well, we take what we have. 4/7 is 120. 1/7, so let's get 1/7 of it, is 30 pages. And the whole book would be 7/7, so multiply by 7, we get 210 pages in total. Okay, we're going to look at that a little bit later as well. But these are all things you should be fairly familiar, fairly fluent with. If we're rounding each of these to 3 decimal places, we go to the third decimal, we look at the one after it. This one, it's a 5, so we round it to 2.895. Same with the next one, we go to the 6. The next number is a 4, so it becomes 0.006, and lastly 5.438. Okay, looking at an exam question then that uses some of these ideas. So we are taking each of these numbers, we have to write them as a decimal correct 2 decimal places. So we're going to be rounding, and then we need to put them in order on the number line. So the first one's done for us. 2.1 becomes 2.10, with the 0 just included to bring us to 2 decimal places. Square root of 5, I can use my calculator, I get an answer of 2.24 when I've rounded it. 243 over 85 gives me an answer of 2.86. Tan of 70 will give me an answer of 2.75. 3 pi over 4 gives me 2.36. 250% gives me a decimal of 2.5. And then my last one, just again making sure that you're, I suppose, happy with typing these into the calculator as well. They're all in around that 2.5, kind of 2 point something. And we have to pick 5 of them and mark them on the number line below. So let's look at our kind of centimeters or our squares that we have and just make sure and kind of see what each stands for. So that's about 2.1, 2.2, 2.3, 2.4. So let's go with 2.1. Let's go with A here. Then we have 2.5 is F, so let's put that one here as well. Then we'll pick another 1 or 2 of them to do. So 2.5, that's 2.6, that's 2.7, that's 2.8. So 2.75 here would be D. So there's another one done. Let's pick another one. So we'll do B, maybe 2.24. So if this is 2.1, this 2.2, this 2.25. So it's around about here, given here. So that's fine. We're putting B there, and then we'll pick one more, maybe near the end there. So we have the 2.75, maybe the 2.86. So that was 2.8, and that was 2.9, so 2.85. So around about there would be C. Okay, so you're just picking 5 of them, marking them in as accurately as we can, I suppose. And if you want to even add in, we could add in maybe what each of them is, just to make it clear kind of where we're going for. But we can kind of, I suppose, see that from the table already, what numbers we're aiming to get at. That's this there. Okay. Significant figures then. Significant figures is similar to rounding, and it's a particular type of rounding, and it's where we consider different digits in the number to be what we'd call significant. So when we're rounding to the nearest million or 100,000, we might be rounding to the nearest significant figure, and we include the required number of significant figures with any other number becoming zero. So if we're given 223,642 and we want to round it to the nearest, the nearest 10,000, then we might round it to 230,000. We wouldn't, and then we just leave the rest of the numbers as zero. So the first significant figure is what we call the first non-zero digit in the number. So if we have the example here, 3, 4, 5, 6, 7, 2, to three significant figures, it would become 345,000. If we were looking at 0.00435 to two significant figures, the first significant figure is the first non-zero number, which is the 4. We can't round it to 0. We can't just round it to 0 altogether. We have to include some of the numbers. So the first significant figure is the first non-zero number. If we have a 0 after that, that will be significant, but only because it's come after the first significant figure. The next one then would be the 3, so it becomes 0.0044. So let's just see that in action then. So for the next part, 76482. So if we're rounding 76,482 to two significant figures, well, we only want to have 2. So it's going to be 76, and we're not going to round up because the next number is 4, so it just becomes 76,000. Okay, we're rounding up in the same way that we were in the previous part. The next one again, so to two significant figures. So the first significant figure is 1, the second one is the 0, and after the 0 I have a 5, so I'm going to be rounding up, so it becomes 1.1. Okay, 1.1, and lastly 0.000502, so 5 is my first significant figure, and the 0 will be my second one then. 50. Okay, so we can see that in that case the 0 did count because it came after the 5. Once we've had a number that's not 0, then any zeros after that are considered significant because they're holding a place value. Up until that point, if we rounded to those zeros, we would have no number at all. So that's kind of the idea with those ones there. Okay, we're going to push on. We're going to kind of get two things together. So we're going to look at ratio and proportion because it's kind of related to our fractions and our decimals as well. So we're going to look at that section in this part too. And I'll put a little maybe kind of note for it here. So ratios show how things are divided or shared. So if we're splitting things out, we might split them out in a certain ratio. So ratios are things like 2:1, 3:2. Okay, but it also comes up in terms of if I'm dividing out a prize and maybe you get 3 times what I get and things like that. And when we're writing a ratio, we're always going to write them in their simplest form and as whole numbers. So we wouldn't write a ratio as 1/2 is to 1, for example. Okay, 1/2 is to 1. We would write that up. We would write it maybe as 1:2. We would write it as a full number. Okay, whole numbers in their simplest form. When we're solving questions involving ratios, we need to remember that each part of the ratio is kind of can be described as like a part. Okay, so if we're looking at a ratio like 3:2, what that really means is that one person gets 3 parts of whatever we're looking at, the other person gets 2 parts of whatever we're looking at. And it also means then that in total there are 5 parts altogether. So if we have a prize or an amount of money or a cake or whatever it is that you have to divide out, the first thing to do is to work out how many parts do I need altogether? How many parts do I need to split this into? So for this one, if it's 3:2, there would be 5 parts altogether. Then once we've done that, we can work out how much would be in one part then. And once we have that, we can work out 3 parts, we can work out 2 parts, we can work out any number of parts that we want. But that's kind of the key to the start of it, is first of all, work out how many parts or how many shares do we need to have all together. And if we want to divide it, then we calculate the number of parts and then we'll use that to find out the specific divisions or the specific shares or the specific elements of it that each person will get. So let's just see it in an example because it makes it, I suppose, a bit clearer for us. So we have 2 different ways of looking at it. So using the ratio, if we have 4,500 to divide among 3 charities in the ratio of 2:3:4. How much money will each charity receive? Well, we look at that. So if it's 2:3:4, well, the first charity gets 2 parts of the total amount. The second charity is going to get 3 parts of the total amount, and the fourth charity, or the third charity, gets 4 parts of the total amount. So altogether, I need to have 9 parts. Okay, so I need to have 9 parts in total. So that's me adding up my ratio. So if I take my total of 4,500 and if I divide it by 9, I get €500. And this is going to be 1 part, or 1 share. 1 part of my total amount is €500, because if I'm going to divide it in 9 different ways, or into 9 different parts, I suppose, in total, then €500 will be 1 part. So what that means for me then is 2 parts is going to be 1,000, 3 parts will be 1,500, and 4 parts is 2,000. And if we add those together, we should get back to where we started, because obviously if I've divided out the prize between these 3 charities, then if I add up how much each charity got, it should still be the total I started with. It can't end up that one of the charities, or that any of the charities have gotten more than we intended. It can't end up that I've split out more money amongst the charities, and also I've split out all the money, so I shouldn't have any left over either. So when I add up those shares again, I should get back to the total amount that I had at the start. What we have here is what we were looking for, is how much does each charity get? And this is the amounts then that each charity got. So then if we were given maybe a name for the charities, we could make it a bit more specific and say, you know, charity A got 1,000, and so on and so forth. Another slightly different but related way to do this is to use what we'd call a proportion. So proportion would be to take our ratios and maybe rewrite them in terms of fractions. So we can use what we've done in the previous part and work out the total amounts and the total number of parts that I need, but then we take the ratios and rewrite them as proportions and say, well, in terms of a fraction, what fraction of the total amount will each charity get? And we can see then, you'll see that we get the same answer either way. So again, starting it off the same, we add up and we see how many total parts do I need, and there are 9 parts in total. So what it means is that the first charity is going to get 2/9 of my total amount, which is 4,500, and we can just sub that into our calculator and we get 1,000. Okay, the next charity gets 3/9, which is actually the same as 1/3, and again we can put that into our calculator and get out our answer of 1,500, and same again with the last part, 4/9 of the 4,500, and we're going to get 2,000. And again, if we added it all up, we get back to the same amount. So getting out the same answers there, but instead of getting this idea of the 2 parts, 3 parts, 4 parts, we're just getting it as a fraction. So the first charity is getting 2/9 of the total. The second charity is getting 3/9 of the total. The third charity is getting 4/9 of the total. Okay, but it's the same idea. We're dividing that amount by 9, we're multiplying by however we're looking for. It actually just works out as the same steps, just kind of phrased or kind of put together slightly differently. So if we're trying to find the total amount, and if we've been given the value of a certain number of parts, then we must find the value of 1 part, or 1 share, and we use that to find the rest. Okay, so same as we kind of did there, we were looking for what is 1 so that I can find 3, what is 1 so that I can find 4. Here it's going to be the case that maybe we're not given the total, but we're given what one person got, and what they got represented 4 parts, or represented 4/9 of the total amount, and we want to work out what was that total amount, what was 9/9. That's the kind of idea we're going for here. So Anna, Billy and Connell decide to split a pizza, and they agree to divide it according to the following ratio, so 2, 3, 5. Okay, and they're paying it in order. So Anna's getting 2, Billy's getting 3, Connell's getting 5. So Connell was hungry, it's fine. So Anna is going to pay the 2 parts, and she paid €12 for the order. Okay, so let's work out the total cost of the order. So 2 parts, or 2 shares of my whole order, would be €12. Okay, 2 parts would be €12. So if I want to find 1 part then, or 1 share, 1 part would be divide that in 2, which would be 6. How many do I need altogether? Well, we can add up how many shares there were altogether. 2 plus 3 plus 5, which is 10. So 10 would be 60 euro. Okay, a slightly different way of thinking about it is that Anna's paid 2/9, which is 12. 1/9 again is 6. So 9/9, or sorry, not 2/9, 2/10. Oh my god, it's all going wrong. 2/10, sorry, let me go again. There we go. So 2/10 was Anna. So 1/10 is the 6 euro, and 10/10 would be the 60 euro that we had at the start. Okay, so following it through that way. How much do Billy and Connell need to play it? Well, Billy's going to get 3 parts. So 1 part was 6, so his 3 parts would be the 6 euro by 3, which is 18. And Connell's paying 5, so Connell's getting 5 parts. So 5. Oh, where are we going? Where are we going? Connell's not going to pay at all. Connell's getting 5 parts. So 6 by the 5, and we get 30. Okay, so that's what we're getting for each person. So Anna paid 12, Billy paid 18, and Connell paying 30. And if we add those together again, we get back to our 60 euro that we had. So we can see there what was important with that one was being able to recognize that Anna's paid 2 parts of the total amount, and using that to work out then what's 1 part and then what's going to be 10 parts. And this is a kind of idea that's going to come up again and again in these questions that we're doing. We'll see it when we do kind of currency exchanges. We'll see it when we do different things to do with tax and different things later on. And it's just about working out maybe the value of one thing. So we call maybe a unit equation. So working out what is the value of 1 and using that to find however many that we want. So if we look at this exam question, then 752 tickets were sold for a show. The ratio of adult tickets sold to children's tickets sold is 3:1. Find how many adult tickets and how many children's tickets were sold for that show. So let's go through this again. So there are how many tickets altogether? 752. These tickets are going to be split out, okay? They're going to be divided out. So some of them are adult tickets, some of them are children's tickets. We're told that the ratio is 3:1. So there were 3 adult tickets for every 1 child's ticket, if you want to even think about it that way. So what we have to look at is maybe how many were there in total. How many parts are we looking at? Well, we have 4 parts in total. Okay, if we want to use our fraction or proportion type, that means 3/4 of the tickets were for adults, 1/4 were for children. Okay, so 3/4 of the tickets were for the adults, 1/4 were for the children. So let's work out then what is 3/4 of my tickets, my 752. Let's just sub that in and follow it through. We get 564, and 1/4 of them were for the children. So again, let's follow that one through. I just sub it into my calculator, 188. And I can add those together just to make sure that we do get that same answer, and we do. We get back to our 752. So those are our 2 results, 564 for the adult tickets, 188 for the children's tickets. Okay, so as with the kind of other questions, it's just starting them off that way, finding what is the total, and then either using the fraction proportion when we did here, or using that parts idea that we had in the previous one. And you get the same answer either way. Okay, you get the same answer either way. If we did the same with this one, we would have to find the value of 1 part first, and then use that to find the value of 3, the value of 3 parts, the value of however many parts we're looking for. Looking at another example, then another exam question. John, Mary and Eileen bought a ticket in a draw. The ticket cost 50 euro. John paid 25, Mary paid 15 and Eileen paid 10. The ticket won a prize of 20,000. The prize is divided in proportion to how much each paid. How much prize money does each person receive? Okay, so there's a lot to go through here, so let's have a look. The ticket originally cost 50 euro. Okay, John paid 25, Mary paid 15, and Eileen paid 10. This is going to be important because the next prize is divided in proportion to how much each paid. So proportion there is telling us ratio. Then we know that the total prize they won was 20,000. So let's have a look. So if we have John, we have Mary, and we have Eileen. And John paid 25 euro. Mary paid 15, Eileen paid 10. Now, one of the first things we said with ratios is we write them as whole numbers in their simplest form. And these aren't in their simplest form because 5 will divide into all of them. So we get 5 is to 3 is to 2. What that means is that the prize has to be divided into a total of 10 parts or 10 shares altogether, if we add those kind of three sections up, those three shares they're all getting, if we add those up, we get a total of 10 shares altogether. So breaking it down then, 20,000 divided by my 10 gives me an answer of 2,000. Okay, so that tells me that I need to split it into 2,000 is going to be one share. Okay, so 2,000 is one share of my prize. I want to know what's the value of 2 shares. Okay, so what is Eileen going to get? Or we'll start with John. We'll start with John. So John is getting the 2,000, but he's getting 5 shares. So he's getting 10,000 of it. Then Mary is getting, obviously the 2,000 was one share. She's getting 3, so she's getting 6,000. And Eileen then is going to get 2, so she gets 2 shares of it, so she gets the 4,000. And if we add those up, it adds back up to the 20,000 prize that they had in the first place. And this kind of makes sense because if we think of it in terms of our fractions, okay, if we decide we don't like the parts way and we want to do it in terms of fractions, in terms of proportions that way, if there's 10 in total and John gets 5 out of the 10, he gets half of it. And half of 20,000 would be 10,000. Okay, same then with Mary. She gets 3/10 of it. Okay, so 3/10 of my 20,000 gives me 6,000. And then lastly, Eileen gets 2/10, which is 1/5 of my 20,000, which is 4,000. Okay, so we can see that you can kind of move between whether you use the fractions, whether you use just that general kind of how many parts is each person getting. Starting them off is the same. For some questions, the fractions might just seem a bit clearer, and for some people, the fractions might seem a bit clearer, and that's okay. It's whatever works for you. Sometimes the fractions maybe are easier in your head to kind of confirm. Like with that one with John. John had paid half of the original ticket, so it made sense that in terms of the prize that they won then, that he would get half of that as well. So half of the 20,000 would be 10,000 for him then. So I suppose going back over all of this, it's making sure you're happy with how to rewrite a ratio, with how to kind of pull a ratio out of a question like we did in the last one there, breaking it down, working out the total number of parts, using either your method 1 here where we work with kind of how many parts does each person get, or using your proportions with your fractions to break it down. And then also being able to work backwards. If you're given one of the values, can we use that to find the rest of the values, find the total value? So these are all the things important with ratios. Then with your fractions and decimals, it's making sure you're happy with rounding significant figures, with rounding your decimals, that you can do all that fairly accurately.